Hello, let's continue our Sudoku adventure with Zippery Slope by GDC. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have this additional diagonal across the grid. We're also placing the digits 1 to 6 exactly once each along this marked diagonal. Not all the diagonals, just the marked one, necessarily. The lavender lines in the grid are zipper lines. So the center it's technically cosmetic, but it's to help you find the center more easily. But the center of the line, whatever digit goes in there, say this was a 5, then the digits that are equidistant from that center must add to the center value. So in this case, these two sum to 5, these two sum to 5, and these two sum to 5. I don't know if I'm going to be able to fill an example, but like 2, 3, 4, 1, 4, 1. That would be one way to do it. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, this does seem pretty limited. So I guess the first question I want to ask is, where does this digit go in this box? Because can't go, actually that might not be the best question. But my point, I guess, is that, what is my point? That whatever digits go on the line can't go in the circle, because we have to add at least one to it to get to the circle, to get to the circle sum. So, but unfortunately, like, this doesn't really help a whole lot. Okay, I thought maybe this one, like, we have this box here. We have all but one digit in these 5 cells. So I don't have a good like way to think about this that's going to streamline it. It's got to be that, though. It's kind of have to do with this. I mean, this clearly has a minimum value to it. It definitely can't be 3 or 4. So it's going to be 5 or 6. The reason it can't be 3 or 4 is I do need 2 ways to add to the circle. I wonder if 4 would work. No, it doesn't. So let's look at 3 first. 3 breaks pretty easily, because this would have to be 1 plus 2, but this would also be 1 plus 2, and this would also be 1 plus 2. Look at all these 1, 2s I just put in this box, right? That's no good. 4, this would be 1, 3, but this could be a 2 plus 2. But now this can't be 2 plus 2 or 1 plus 3, because this sells at least 5. That's no good. So this is 5 or 6. Now, that's kind of interesting. If this was a 5, the 6 would have to go here, because we can't put a 6 on a sum to 5. That doesn't make sense. I'm wondering if if 6 has a limitation. So, well, 5 has only 2 ways to add to it, but I think I proved that it does work. Like, we could do 2, 3 here, 1, 4 here, and 1, 4 here. We'd make some pairs. This would be a 6, but that works. The 6 feels more flexible because there's also 3 plus 3 that can be done. So if this was a 6, we could do like 1, 5 here. This could be, say, 3 plus 3, and this could be 2, 4. Or even these could be 3 plus 3, with these being 2, 4. So I'm not sure I can say much more than this being 5 or 6. Oh, right. And 6 is one of these two, right? Because either this is a 6, then one of these two is a 6, it's this one. Or this is a 5, in which case that forces the 6 in the box to be here. Okay. And that does matter because it affects our rest of our diagonal here. We can't put another 6 on the diagonal. And so this is max 5. And 3 still doesn't work. A 3 would be a 1, 2 here and a 1, 2 here. That's too many 1, 2s in this box. So it's from 4 or 5. Now 4 feels limited, but we have 2 plus 2. So we can do a 1, 3 pair here with a 2 plus 2 here. 5 would be like a 1-4 pair with a 2-3 here, or the other way around. But it does mean we need a 6 in this box, and it's not on the diagonal, and it's not on the lavender lines. And so the 6 goes here. Now again, lavender lines can't have 6 on them, only the circle. So in this box, 6 goes here. All right. In this box, 6 has to go in one of these two. And in this box, one of these two. Okay. These can't have 5 on them either, because we add to at most 5. And so actually 5 ends up in one of these two. So now this actually is a 3 or a 4. And it's the sum of these two. Because it's the sum of these two, I should say, which can't repeat. So these are from 1, 2, 3, and they definitely contain a 1. Removing 1 from the rest of the row. They also definitely contain a 3. One of these 3 has to be a 3. Either this is a 3, in which case, duh, or it's a 4, and this is a 1, 3 pair. So 3 is definitely within here, and so is 1. 2 is optional. But these are not 1 or 3. So starting from 1 through 6, they're not 1, 3, and this one also can't be 6. Nor can it be 5. Right, so none of these are 5, and none of them are 6. So this is where 5 and 6 go. This is 2 or 4. That sounds interesting. So this is always 4? No. No, I think I'm seeing that one of these two is a 4, which is just true of the row. Let's just go through the cases here. If this was 3, this would be a 1, 2 pair. This would end up 4. That's fine. If this was 4, this would be a 1, 3 pair. This ends up 2. That's fine. A 4 would force this to be 1 and this to be 5. I think that's okay. I wonder if I need to do this. Do I need to look at this line, or do I need to update my thoughts about this line? The 5, 6 pair, does that make it an issue to add to 6 here? No, because I can make this a 1, 5, and then like a 2, 4, and a 3, 3 or something. That seems okay. We know that this isn't 5 now, actually. Oh, the pointing 5s, right. I didn't follow up on them. This isn't a 5, so it is a 6. All right, and that makes that 5 and 6. So I think there's still options for how this 6 gets added to. I don't know what we're missing in this box, but it's not this digit. I mean, this is a 1, 2, 3, or 4. I don't know if 1 is possible. I also 3 might be possible actually. No. Is it? So if I wanted to make this a 1, then these are all from 2. These would all be from 2, 3, 4. So this would be a 2, 4 pair, and these would both be 3. Okay, yeah, that's no good. Wait, what? Yeah, wait a minute. Where's the 5? No, we need a 5. They'd be from 2, 3, 4, 5. These aren't 5. This isn't 5 either. So if in this box, 5's in one of these 3, which is going to have to go with a 1 in one of these 3. So if this was a 1, then that would have to be 1, 5 like that. But I think I'm thinking too hard about this. I think we're not here yet. We got the 6, but I'm not sure that that was enough to continue with that line. We know this is 4 or 5. So there's kind of an interaction between if this was a 4, this would be a 2, this would be a 5, right? Because 4 makes that a 5. Oh, so this is always 5, isn't it? So if this was 4, this is obviously 5 because this has to be smaller than it. If this is 2, notice the 4 in the row has to go here. And if 4 in the row is here, that just directly makes this a 5. So this is always a 5, which isn't surprising, but... So we're either 2 plus 3, which I think works, or 4 plus 1. I was thinking about how 2, 3 would make that a 4, but the 2 also just directly makes that a 4, so that's okay. There's like some interaction here that I'm not quite getting. But I'm going to put 1, 2, 3, 4 here to remind myself of the diagonal. Because why not? 5 ends up in one of these two. So this is not 5 or 6. So it's 3 or 4. And these are 1, 2, 3. So where's 4 in this row? It goes here. This is 4 plus 1. That makes that 3 plus 2. That makes that a 4 with a 1, 3 pair. This has to be 2. So these are not the 2 or the 4. This is a 1, 3 pair. Down here, this is 1 plus 2, making that a 3. And this is 4 and 5. Okay. That worked out well. It was this guy. I just didn't look closely enough at it. Let's see, 1, 2, and 4 here. So this could be 1 plus 5, 2 plus 4, 4 plus 2. And same thing here, 2, 4, 5. So this is not 3 plus 3. Oh, and this isn't 3 either. That's not 5, so that's not 1. Because the 1, 3 pair. So these aren't 1s because the 1, 3 pair. 2, 4 pair. And so these can't be 5s. So that's a 2, 4 pair. So this has to be 5 and this has to be 1. That places the 3 there. That's 4 and 5. That's 2 and 4. We get the 2 and the 1. All right, 3 makes that a 1 by the diagonal, making that 3 and 1. All right, up here we need 3, 5, 6. This can't be 3 or 6. So this is the 5. This is 3, 6. Oh, we should be able to finish with Sudoku here. Need a 1, 2. So this 1 tells me that's 2 and 1. Oh, I could have done this 4 and 2. I didn't realize I didn't finish that zipper. But Sudoku did it for me. We need a 5, 6 here. This 5 tells me that's 6, 5. That's 3, 6. We need the 5. Oh, no, not 5. Sorry, what am I doing? I need the 3 and the 4. All right, cool puzzle, GDC. The interaction, yeah, there was some cool interaction going on between the between lines on the diagonal, and then this little sneaky one down here, placing the 4 in the row. That was neat. All right, well, let me know how you did, and if you enjoyed this, why not leave a like, subscribe, and a kind comment below.